So welcome everybody. Welcome everybody. This is Letizia Iaccheri from the Norwegian University of Science and Technology, and I have the pleasure to chair the session Software Engineering Education and Training, Industry Relevant Teaching. We have 5 very interesting talks, and I give directly the word to Richard Glassi from KTH in Stockholm, who will present himself and give his talk. Please, Richard, the floor is yours.
Thank you very much. Okay. So, the title of this paper is Addressing the Double Challenge of Learning and Teaching Enterprise Technologies Through Peer Teaching. I'm Richard Glassi, and this is work in collaboration with Ola Belter, Philip Haller, Matthias Wiberg, and we're all based at the Royal Institute of Technology, KTH, Stockholm, Sweden. Okay, so a very direct question in this talk is, what are enterprise technologies? And this is a bit vague, but basically what I'm talking about here are things like frameworks, libraries, tools, etc. Okay, things that typically have a lot of documentation we have to read. And why this is particularly interesting is when it comes to the students that I teach, these technologies represent a bit of a barrier that they have to cross. Okay, it's quite complicated. This leads to a double challenge. The first one, which I already alluded to, is the learning challenge that students face. If you look in the pedagogical literature in CS education, there's not actually a lot out there on the challenges students face when learning software frameworks, tools, and all the rest. But there's actually, in software engineering at least, there is a rich trend of literature in the challenges, the learning curves that software developers face when adopting a new software framework and the amount of time it takes them to become productive. Also, the second challenge here is the teaching challenge. This is more things that I have to be concerned with, is that if I'm teaching an enterprise technology, I'm first faced with a problem of which learning technology or enterprise technology do I pick. If it's a web application framework, there can be many different options. Once I even pick a web application framework to teach to my students and I make my learning materials, I'm faced with another problem. So version 1 comes out, then version 2 comes out, and then version 2.2. Whatever comes out, and all of a sudden there is a divergence between my learning materials and the framework or enterprise technology itself. So this creates these two challenges. One of the ways that I've used to approach this is to use peer teaching. And traditionally, I would stand in front of my class and tell them about some topic in a very kind of traditional format. And this is okay, but it's not exactly very effective, especially if I want to convey a lot of different technologies. Peer teaching, on the other hand, is the idea that the students themselves should take responsibility for teaching each other. And one of the nice benefits of this is that each student or group of students can become proficient in different technologies and teach each other. Meanwhile, me as the teacher, I can go and enjoy my hot cup of coffee whilst the learning happens. Okay, so that's the principle at least. In terms of context from where this work is coming from, we started the Software Development Academy at KTH in 2017 in response to the refugee crisis happening in Europe. And the idea here was there was about a lot of students coming from countries like Syria with incomplete degrees, and we created a 3-month program to train them to become junior developers. So that's the kind of the teaching context. So it's very much a kind of boot camp style environment. One of the challenges we noticed was we went from basic Java to Android in 3 months, and we of course met this learning curve. The students really didn't have the skills to take on the Android framework. So that led to the creation of a new module that was only going to take 1 week long, but the whole idea was we would introduce students to the notion of all these enterprise technologies and show them that they could actually teach themselves. So me as a teacher on Monday, I've introduced the concept of this module to them. There's 36 students, so we divided them into 6 groups of 6 students, and we selected 6 enterprise technologies. And the whole idea is that they would create 6 workshops for each other on these technologies. The workshop itself was about 2 hours in length, and the whole idea is the students should introduce the technology, why it's important, and also they should talk about the rivals that are out there so that people would be at least aware that there would be different choices. When it came to the main activity, we actually encouraged the students to reuse a material as much as possible, official tutorials, online material, so they didn't have to produce anything. And then at the very end, they actually made a peer evaluation of both their learning from having their peers as their teachers, but also to reflect on their experience of teaching itself. Okay, back to the plan. So this created a little bit of stress because really all they had was the remainder of Monday and Tuesday to prepare these workshops. So a lot of stress. Technologies themselves, we went for a wide variety. We had Docker, we had a workshop on Maven, we had a workshop on Hibernate, it's going to be hard to fit in, and we had a workshop on MongoDB. And to round off the week, we stepped things up a little bit, and we had a web application framework. So we had the Play framework, and then finally, kind of the Friday treat, we had a workshop on deep learning for Java. Okay, so quite ambitious towards the end. What was kind of nice about this for me as a teacher is that I actually only attended the 10 minutes at each of these sessions. So I only really spent 1 hour of my time making sure everything was set up, and about maybe 60 minutes over here introducing the module. So for me, this was very efficient. But what were some of the outcomes of this experience? Well, the first thing, at least from my perspective, the things I could report most accurately on was the time spent was, for me, super efficient. This is a boot camp style education, so the students are attending 5 days for 8 hours a day. So they're in classroom all that time learning. But for me, this just cost me 2 hours. Of course, there was the prep time beforehand, where we had to actually sort of test out the idea and make sure it would actually work. The other thing from my perspective was the expertise. A lot of these technologies I've not even used before myself. I'm obviously aware of them, but as a teacher, I didn't have to become an expert in Docker or Maven beyond the basic concepts. I knew there was good material out there for tutorials, so I knew the students would find it. On the student side, their experience, of course, they had a lot of stress. We really put them under time pressure here. It was not a lot of fun for them at the start of the week. Also, we had various IT issues. These are typical things such as downloading 36 students downloading deep learning for J and all the data sets over a common access point was a bit of a problem. And of course, everyone had different experiences of installing these things. But actually, this worked out quite well because they had 6 teachers in each of the teaching teams and themselves to help each other. So they resolved all these issues. Okay, I only have a little bit of time left, at least for the 8 minutes, but I'll use that just to maybe, the thing I noticed, probably the key finding of this is the students by the end really had a sense that they could actually teach other students basic concepts about these enterprise technologies. And they did that in a very short amount of time. talking to the students, they had this sense of growth of confidence and feeling that actually all these scary buzzwords and terms suddenly became a little bit less scary when they actually worked together. Now, the context of this was in a university context, but due to the bootcamp style, I actually think this would work quite well in IT training for software developers picking up new technologies, where you don't need to hire an expensive expert, but you can use this type of configuration set up to get your developers to teach each other. Okay, I'll stop there because I don't want to eat up too much of my time. But just to remind you, I'm Richard Glassy, and the paper was addressing the double challenge of learning and teaching enterprise technologies through peer teaching. Thank you very much.
So if there are questions on the chat, you should be able to see yourself, Richard. I have a question, but I give the priority to the other people.
Okay, I'm looking. I don't know if I can see any questions right now.
So maybe in the meanwhile, I can ask my own question. I think this is very, very interesting. And I like very much the social dimension, that this is not only for the Swedish students, but also for the refugees who come to Scandinavia, to Sweden, and we want to teach them as much as possible. So I really enjoyed reading your paper and listening to your presentation. My question is a very practical one. You say that you come to the workshop and you can see in 1 hour that the workshop is set up. So how do you evaluate that the workshop is set up? And I wonder if any times you have to say, no, stop, this is not good enough. In order to set up your workshop, you have to do this and this and this.
Okay, so I guess the first thing is, because these were mostly adult refugees as well, there was a lot of responsibility in the group. But also we actually had teaching assistants sitting in the laboratory just in case there were any problems. So we did have a presence, but it wasn't anything that I needed to be concerned with. I think the biggest problems actually were technical problems that the students just we learned very quickly that we should have probably made a homework the night before, download this software, and then we'll fix the installation. But actually, I think the group spirit we already had in the room, this is a 3-month module, and this is coming towards the end. So the group was already quite happy working together and solving problems. So in terms of quality, we were happy with what we saw in the presentations. We were confident they were engaged. And then we also had the evaluation at the end, so we could, at least afterwards, discover if there were problems. But yeah, the students all seemed really positive when we talked to them. They were just, why don't we do this normally in university?
Thank you very much. Do you see other questions on the chat?
Unless, I don't know if I can refresh, but I can't see any direct questions.
But then, since time is 13 past, I think we should give the word to you, Mair. And we thank you very, very much. And if people have questions for you, you will be available by email and on the ICSI chat. Bye bye, Richard. Thank you very much.
Yeah. So, hello everyone. My name is Umair, and I shall be presenting our work on characterizing the pedagogical benefits of various adaptive feedback tools designed for compilation errors made by novice programmers. So first, I shall start out by explaining the necessity for addressing compilation errors, followed by exploring some of the existing adaptive feedback tools designed for compilation errors. And then I shall explain our large-scale user study setup, where we deployed these adaptive feedback tools and measured some learning benefits not only using some traditional metrics such as average time taken, but also some novel metrics designed by us. So first, many of you might be wondering what is the big challenge with compilation errors, right? The compiler not only shows the exact line number where the error occurred, but also a helpful error message that tells you what the mistake was, as well as what the repair that is desired. While this might be true for most of us over here who are expert programmers, this is not necessarily the case for novice programmers who are not only, like especially students who are learning their very first programming language in a university course. So let's take a look at what happens when these novice programmers make a mistake. So over here is an example where a student is trying to multiply two integer expressions, a plus b and a minus b. This is typically the case in an introductory programming course where students assume that two integer expressions, if they are written in parentheses, it implies multiplication. However, as we know, most programming languages desire an asterisk operator in between to make the multiplication happen. The compiler over here is treating this as an illegal function invocation and is talking about functions and function pointers to a student who barely has the grasp of an integer data type in the first week of course, right? So clearly this is not helping them, and hence they have to turn to human tutors or instructors for help, which is not scalable in a large classroom setting. So recognizing this need, various adaptive feedback tools have been proposed in literature. The most popular one of them is called repair-based feedback, where it takes the incorrect program written by the student and produces the exact repair or the fix as feedback. So Tracer, which was published in ICSEAT 2018, is one of the state-of-the-art tools in this domain. So in the first row where the student is missing an asterisk operator, Tracer can exactly predict that asterisk needs to be inserted at the right location. Similarly, in the second row where the student has forgotten to add a %d format specifier for printing an integer variable, Tracer is able to correctly predict the repair required and at the right location. So this is the first type of repair we shall be looking at, first type of feedback. The second type of feedback is known as example-based feedback. So Texer, which was recently published in ASE 2019, is the state-of-the-art tool in this area. So given an incorrect code, Texer tries to generate examples of code taken from other students that not only suffer from the same mistake, but also desire the same repair, similar repair. So in this first row where the student forgot to write an asterisk operator, Texer tries to demonstrate through examples the correct usage of an asterisk operator. Similarly, in the second row where the student doesn't know how to print an integer variable, Texer is trying to demonstrate through example how to print a string variable. The hope is that the student can look at these examples and transform this knowledge onto their own problem at hand. So while these two tools exist in literature, what we set out to do was measure the learning benefits of giving this feedback to actual students. And hence we carried out a large-scale user study where we deployed these feedback tools in a live setting. This user study was carried out at an Introduction to C programming course at IIT Kanpur, which is a large public university in India, where more than 400 students credit the course every semester under the guidance of more than 40 expert human TAs. An important component of this course is 7 weekly labs where students have to submit assignments during a 3-hour window. So in our user study setup, in the semester 2017 to 2018, in spring semester, half of the students were randomly given immediate feedback from Tracer, which is a repair-based feedback, while the other half of the students received example-based feedback from Texer. And in case they were unable to resolve their errors even after 5 minutes, then human tutors would step in and help them out. As a baseline, we take the previous semesters where no automated feedback tool were deployed and only manual feedback was provided by tutors as the baseline. So across all semesters, the syllabus was the same for this Introduction to C programming course. And all of the semesters submitted their assignments on the same IDE called Pruter, where on the top right pane is called the coding pane where students type in their assignment. And in case there is a compilation error, it is flashed in the bottom right console pane. And the experimental group receives either repair-based hints or example-based hints in the left side pane. The baseline group does not get to see either of these hints. So finally, what are the results? So using average time taken, we can see that the group of students who received repair-based feedback made more than 7,000 compilation errors during the 7 weeks of course, and they took on an average 75 seconds to resolve their compilation error. In comparison, the example group of students made more than 8,000 compilation errors in the same duration of 7 weeks, and they took on an average 78 seconds to resolve their compilation errors. This is significantly lesser as compared to the manually tutored students who took on an average 85 seconds in one semester and 103 seconds in another semester. So while this average time taken presents one metric, we use some novel metrics to understand this better. So one such metric is error survival probability, which plots a distribution of time instead of a single average time. So over here in the plot on the right hand side, the x-axis is telling how much time was spent by a student on resolving their error. The y-axis tells us what is the probability of the error surviving after the student having spent t amount of time. So from the plot on the right, we can see that automated feedback group has 7.5% additional chance of resolving their error after having spent 50 seconds on their task. And interestingly, during the exam event, where all kinds of feedback, whether it's automated or human feedback, were withdrawn, all the groups, the baseline and experimental groups, perform similar, and which leads us to believe that the advantage observed during the lab setting is primarily logistical, wherein it's about faster delivery of feedback rather than a better conceptual understanding of the error and the repair. So finally, I would like to present an individual analysis of individual errors. In the right-hand side plot that you can see, each dot refers to a unique compilation error type, with the y-axis denoting its estimated hardness and the x-axis denoting the potential performance improvement of the feedback tool group over the human tutored group. So from this graph, we can see that the performance advantage of automated feedback tool group increases with the hardness. In other words, when the compilation error is quite hard, our performance improvement is achieved using automated feedback tools is larger as well. So in conclusion, we conducted a large-scale randomized control trial of 480 students, where half the students received repair-based feedback, whereas the other half received example-based feedback. So the automated tutored group not only resolved their errors faster, but the advantage increases with the complexity of the error. The entire user study dataset as well as analysis scripts are released on this GitHub URL to aid further research across all semesters. And finally, I would like to thank our collaborators, Dr. Sumit Gulwani and Dr. Abhi Rao Chaudhary, for their support in this project. Thank you.
Thank you very much. Can you see the questions any questions on the chat?
Yes, there is a question in Slido, so I'm going to read that question. So it is expected students would resolve error faster, but do you think auto-suggesting a correction would really help the student to learn with their own errors?
So the last part, could you repeat, Sophie?
So
what could help?
Do you think auto-suggesting a correction would really help students to learn with their own errors?
Mm-hmm. That's an excellent question. So I think it does help, because even in simple programs, right? So sometimes the students just lack the understanding of what a for loop syntax is. So if they look at the correct syntax, maybe they will learn it for the next time how to write a better thing. It's not about, so compilation errors are not like logical errors where it's about knowing new things. It's the repeated knowledge of what the correct syntax is. So over time, the students might make mistake, but many times it's much better to give a feedback, what we felt, rather than giving no feedback where the student just gives up learning because of no feedback availability.
Thank you very much. Thank you very much. I think that your time is over. So if there are more questions, I think people can ask to you offline. I really congratulate you for your study, very rigorous, many subjects. It's really something to look up to. Congratulations. So I would like to give the word to the next speaker now. Yes, the next speaker is Rajish, and he will introduce himself and the title of your presentation. Please.
Am I audible?
We can see and we can hear you.
Okay, thank you. Hi, I'm Prajesh Prasad from the Interdisciplinary Program in Educational Technology at IIT Bombay, India. And I will be presenting a paper, VeriSIM, which is a learning environment for comprehending class and sequence diagrams using a pedagogy called design tracing. So let's start with an example of a graduating student who is entering the workplace. It is Ajay's first month on the job. He is introduced to his team, and instead of working on a new project, he has to work on an existing project, and he has to add 2 new software features to the existing design. Now, this scenario is not very uncommon for novice software developers. When they join the software industry, they usually join large teams. They spend their first several months resolving bugs and writing additional requirements. Now, these tasks require them to explicitly comprehend different software design diagrams. However, we see that developers, they try to avoid comprehension as much as possible. And we also see that there is a lack of training in software design diagram comprehension. And when we look at expertise in software design, we see that experts, they create detailed mental models and perform mental simulations on these models while comprehending design diagrams. They also employ various reasoning techniques like simulating scenarios in the problem and switching between different diagrams in order to understand these diagrams. Hence, to summarize, we see that experts, they create an integrated model of the design and simulate scenarios in the design. With this background, we have developed a pedagogy called design tracing. So what is design tracing? So if you consider this scenario, which is a scenario for an automated door locking system, where the door is locked and the user selects the unlock option and enters the correct passcode. In design tracing, learners construct a model for this scenario, which is similar to a state diagram. I will go into the details soon. But our main hypothesis is that tracing such scenarios in the design will help students to comprehend class and sequence diagrams better. We have implemented this pedagogy into a web-based learning environment called VeriSIM. VeriSIM is freely available for anyone to use in this URL, verisim.tech. In VeriSIM, learners go through 3 stages. In the first stage, learners go through the requirements, the design diagrams, and scenarios of an automated door locking system. In the design tracing stage, they go through 4 challenges where they progressively learn to construct a model for a given scenario. In this slide, I will just give you a brief overview of the learning environment. In the design tracing stage, the first stage is explore the model. As you can see on the screen, learners are introduced to the class diagrams and the sequence diagrams of an automated door locking system. They are also given a specific scenario of this design. Now, this state diagram models this scenario. The states correspond to variables and their values, and the transitions correspond to messages in the sequence diagram. The learners can click on the Run button in order to visualize the execution of this scenario. We can see As the learner clicks on the run button, the sub part of the scenario is highlighted as well as the state diagram, and appropriate parts and the corresponding parts of the sequence diagram and the class diagram are highlighted with relevant values. This enables learners to develop an integrated understanding of the class as well as the sequence diagram. After this, they solve certain evaluation questions, and then they move on to the second challenge. In the second challenge, learners correct a given model. We see in this case a state diagram is given, but it is incorrect and it contains certain errors. What learners do is they click on the edit button and they edit the states which contain the errors. So in this case, we see that the lock, it should be turned to true. The learners can edit other states or then click on the run button to get feedback about their model. The learners continue to do this until they have correctly modeled the entire scenario. So in the third challenge, the learners have to complete an incomplete model. We see here that the states do not have variables and values associated with them. And finally, they have to construct the entire model from scratch. We believe that as learners progressively learn to construct the model, they are able to understand the relationship between this class and the sequence diagrams for different scenarios. So we conducted a study to study the effect of VeriSIM on learners' comprehension of these design diagrams. We tried to answer two research questions. Firstly, does it improve learners' ability to trace a given scenario? And what are students' perceptions of the usefulness of this technique? We conducted a study with 86 final year CS students, and all of them were familiar with class and sequence diagrams. So firstly, they filled a pre-registration form. There was a pre-test, followed by interaction with VeriSIM, followed by a post-test, and which ended with some focus group interviews. In the pre-test and the post-test, similar design diagrams were given, and the question in both the pre-test and the post-test was to execute a given scenario. In order to answer the research questions, for research question 1, we looked at the difference in the pre and the post test based on a rubric, which I'll explain shortly. And to answer research question 2, we did a thematic analysis of the feedback form and the focus group interviews. So this is the rubric to answer RQ1. It contains 3 criteria. Students have to, in order to trace a given scenario, students have to identify relevant data variables, relevant events, and relevant states. And you see, we can see that there are 3 levels ranging from missing to target. Moving on to the results, we see that for the data, event, and the state change criteria, there is an increase in the number of students who have moved to the target levels. And on doing a paired t-test, we saw that there is a significant improvement in students' ability to trace scenarios. On asking them about their perception, students gave positive feedback about this technique. They said it helped them develop an integrated understanding of these diagrams and also helped them identify errors in the design. To conclude, we believe that this pedagogy is useful for students, and moreover, we found a change in attitude in students towards designing and towards modeling. Students said that previously they tend to not give it a lot of importance and they used to directly jump to coding. But after interacting with VeriSIM, they said that there was a shift in their attitude towards modeling. As part of our future work, we believe that this is a precursor strategy and which can be applied to more complex diagrams as well as other examples also. Thank you, and you can access VeriSIM freely here, and I'm open for questions now. Thank you.
So thank you very much. And while we check the chat for any questions, I would like to give you my compliments for your work. That is really well done and well presented. I have read your paper. I want to read it once more. And I have a small question for you about the role of the students. Do the students know that they are part of an experiment, and what do they think about it, of being subjects in an experiment?
Yeah, so we told them that this will be a workshop, and they were not aware of the research questions and so on, but we did give them the pre-test and the post-test, and we told them that we want to understand uh, if this learning environment is useful for them. So, and they were quite helpful in giving their feedback about the system as well.
Thank you very much. Are there any other questions from the audience?
Yes, there is several questions. Let me read the first one. Have you considered the usefulness of including activity diagrams and establishing relationships between the three types of diagrams?
Yes, that is a good question. So we initially started with class and sequence diagrams because the class diagrams represent the structure and the sequence diagrams represent the behavior of the system. And I think activity diagrams also describe the behavior. And I think in our future work, we want to explore how different diagrams can be added into the system. Yes.
Okay, so do you have time to ask additional question?
In fact, time has passed. Now is 36. So we have to go to the next speaker. I hope that Prahish will answer this question offline. Later, I would like to switch to the next speaker, who is Williamson Silva from UFAM. And the title of the presentation is Towards an Open Repository for Teaching Software Modeling Applying Active Learning Strategy. So please.
Hello, everyone. Thank you. My name is Williamson Silva. I will present our paper Towards an Open Repository for Teaching Software Modeling Applying Active Learning Strategies. So I will present the context of this research. Okay. Hello, I'm Professor Silva. Every year, I teach in software engineering and software modeling using UML diagrams. I realized that I could adopt active learning strategy as a way for significant learning. However, I perceive a number of specific challenges to apply this strategy in my class. Some challenges faced by instructor are less preparation time, less time requirement to implement the strategy, and the few criteria to decide which are the best active learning strategies to design and to implement in the classroom. So, based on this context, our research question is how to support instructors to implement active learning strategy for teaching software modeling. To help us, we use the design science research approach. This approach is used to create and evaluate new artifacts in information system and educational research. In our research, the artifact we propose is OpenSMALS, Open Repository for Teaching Software Modeling from Active Learning Strategies. OpenSMALS is an open repository that aims to help instructors to implement active learning strategy in their teaching context. Also, OpenSMALS provides some specific guidelines on how a instructor can apply the strategy in the other artifacts. We also define two requirements to help us to evaluate the OpenSMALS. The first requirement is OpenSMALS should provide procedures on how to apply teacher strategy, and it should provide tools to support the use of this strategy. And the second requirement is OpenSMALS should enable instructors to identify the most appropriate active learning strategy to facilitate the use of this strategy during teaching software modeling. To develop small, we use active learning strategies in identifying the systematic mapping. Then, based on this strategy, we create a conceptual model, and after that, we create a decision tree and create open small questionnaire. Based on the answer provided by the instructor, the open small questionnaire recommended a set of strategies, and the instructor can go to the open small portal for more information about this strategy. To evaluate open small, we conduct a pilot study and two empirical studies. Each of them results in a version of open small. In each evaluation, we conduct a semi-structured interview. After that, we carry out a qualitative analysis, and the result of the qualitative analysis gave us insights to improve open small. In the first empirical study, we identified some negative results. For example, the suggestion of the questionnaire open small was too generic, by reported the instructor one. So, by analyzing the results, we realized that requirement 2 was not achieved. Then, we elaborate and validate a new version of the decision tree and carry out a first empirical study. Regarding the results of the first empirical study, we found some evidence reported by the instructor in the use of open small. For example, open small recommended strategy according to the teaching context reported by the instructor 3. And open small assist in the classroom. The instructor 2 commented, the open small is very objective because it asks you how many classes you want to use. This is good because it enables you to tailor strategy according to your monthly planning. So the results of the first empirical study provide us a lot of evidence about how can improve open small. For example, the suggestion 1, open small could show how the instructor can conduct a student organization. The suggestion 3, the recommendation of the strategy should take into account the background of the instructor. So we implemented the improvement in the new version of open small, and in this moment, we decided to turn open small in an open repository, in which all the artifacts that are necessary to implement the strategy are available to the instructor. And in the second empirical study, the results show that the material provided by open small help instructor during the implementation of this strategy. The instructor 2 commented, the open small provided me several support documents to apply the strategy. So this is a current version of the open small v4, and some artifacts provide for the instructor, like modeling scenarios, evaluate questionnaire, and a data collection sheet, and others. And based on the requirement 1 and requirement 2, we observed the instructor better accept open small. So we decided not to perform a new empirical study, only perform the improvements in the open small. And to answer our research question, how to support instructor to implement active strategy for teaching software modeling, we can suggest to the instructor use open small, because open small was designed to address the practical challenges faced by instructor, and the open small portal is a tool that guides instructor on how each of the active learning strategies should be implemented in the classroom. And finally, we would like to invite you to try the Open Small questionnaire and the Open Small portal. You can access Open Small on this website. So, Open Small is ready to be employed by you in your software engineering literacy or in your software engineering course. Let's collaborate. Let us use Open Small to help the other instructor. The other reference using this presentation. And thank you.
So thank you very much. I cannot see the questions now. I am on the system, but I cannot see any questions from the audience. Do you see any questions from the audience?
No.
No, so my questions is about future work. I like very much that you conclude by inviting other people to use your system and to contribute. And I wonder if you have plans to replicate your studies, maybe in other universities in your country or in other university abroad. Have you been thinking about this? And if yes, in Norway would be interested in cooperating with you. So what do you think about extending to other countries?
Okay, thank you for the asking. Where we intend to carry out another empirical study in another university, yes. And because we intend to understand how the other instructor can use OpenSmall, how they use it, how the factor influence they use it, and we intend to implement another strategies also in the OpenSmall.
Thank you very much. Thank you very much. So I hope we will talk later, and you will, and other people also will talk to you later. And now we can go to our next. If I don't think that new questions have arisen, so we can go ahead to the next and last presentation that will be presented by Antti Knutas from the Lund University in Finland. And I kindly ask you, Antti, to share your screen and go ahead with your presentation.
Thank you. Can you also give me a permission to enable my video, please?
Yes.
Okay, there we go. Thank you. Now it's working. So let's go for the share screen, and can you confirm that it's visible fine?
Yes, I can see it
Thank
very
you.
well.
So hello all, I'm Antti Knutas, and I'm really privileged to present our study on what prevents Finnish women from applying to software engineering roles. First look into our data, and I'm the middle author. So before going into the actual study, I want to acknowledge the role of the two other authors who did a big part of the work. So a couple of words about motivation and background first. So Finland is considered an equal country. It has a very good reputation internationally, but there are still known problems in the gendering of certain professions, such as women in Finland still face issues in obtaining software engineering roles, with the situation much less favorable to, for example, Lithuania, where tens of % more of women are represented in scientist and engineering roles. And there is an initiative called Mimmit Coda, which is aiming to widen participation. And to help this initiative, we conducted a survey to understand which factors contribute to literature. And based on this, we drew on literature to build a series of hypotheses which experiences directly or indirectly affect the willingness or ability of Finnish women to apply for software engineering roles. We framed the survey around issues of gender stereotyping, attitudes, and efficacy to formulate our hypothesis and survey constructs. And we conducted it with the Software and E-Business Association to gain as wide coverage for our survey as possible. So we had 3 layers of survey constructs. First, early school experiences, then higher education experiences, and finally, working life experiences. And our hypothesis is that these affect different types of attitudes and perceptions of self-efficacy, which then in turn have an effect on tendency to seek work in technology careers. And in here is our research model, we use the path modeling approach, which allows to visually represent and test these paths of consequence. So each of these constructs is composed of several variables, such as our hypothesis is that negative experiences affect 3 types of attitudes, such as these emotional types, behavioral, such as tendency to seek work, or cognitive attitudes, or this intellectual awareness that it is indeed more difficult to seek equal positions. And equal opportunities in careers or education, which both affect attitudes and these perceptions of self-efficacy. And our ultimate hypothesis, you would say that these 3 constructs and these 2 constructs moderate the impact of these experiences on tendency to work in technology. And so we have several hypotheses because each line is an individual hypothesis. We use the partial least squares path modeling method to validate our hypothesis and analyze the model. Due to time constraints, more about this in-depth testing process is available in our research paper. So the hypothesis testing outcomes. Our key hypotheses were confirmed as true, or hypotheses were retained. Let's look at the constructs first. So R squared, or explanatory power, is moderate in both cognitive attitudes and working in technology. And it is small but valid in computer self-efficacy. This means that negative experiences and equal opportunities affect working in technology through specifically cognitive attitudes and computer self-efficacy. And in here, you can see the lines that were considered valid hypotheses. Thin line has a small effect size, and medium or slightly thicker line here has a moderate effect size. So our key hypothesis was confirmed as true, and you can find detailed statistics and tables again in our research paper. And maybe one key thing also to consider is that these green lines are positive impact, and orange means like opposite impact or opposite polarity. This means that cognitive attitudes are a kind of a negative perception, in the sense that the higher this construct is, the more the respondent said that they know that it's more difficult, and this computer self-efficacy is a positive perception about themselves. So the higher the self-efficacy is, the higher the tendency to work or apply for technology careers. So to go into the discussion and also highlight our contribution, indeed we were able to state that also in the Finnish context, negative early experiences and perceived lack of equal opportunities did have an impact, and it was specifically mediated through cognitive attitudes and computer self-efficacy. And this will hopefully provide more evidence to the Nimitkoda campaign, and also more evidence in the local context when these issues are discussed further. And in academic context, we have our main contribution is we analyzed mediating constructs in addition to direct effects, because there are many excellent studies available, but these are regression style direct evaluations, and these kinds of mediating effects have been proposed in literature, but not yet analyzed empirically. And our findings support earlier theoretical work, for example, by Cheruan et al. And Patitsas et al. In 14 and 19, that say that improving the situation for women in software engineering is not simple. It's not about only like this job selection process, but it requires broad strategies that seek to change the perception of society as a whole, who can and cannot participate in technology. And also, please find the address for our preprint here. So thank you for your attention, and I'd like to welcome any Q&A. And actually, regarding that, maybe let's have a look at the
while you have a look at the chat, I want to tell you that I read your paper, and I have already written to the first author to invite here to a newly started cost action we will have in Europe about gender issues in computer science. I think you are doing really an excellent work, because most of us are doing actions, but you are in fact doing science about gender and computer science. So I think your work is pioneering work, at least here in Europe. I really appreciate what you are doing. Way you are approaching. Do you see any other questions? Because I don't.
I see one in Slido, and thank you for your kind words. I'm really excited to be part of this research. And there is one in Slido, such as, do you expect similar results in other geographical locations, such as model can be applied to other unrepresented minorities like indigenous people? And my gut feeling is that yes. For example, there is the indigenous people of Sami people in Finland, and I think you would get different outcomes, like different paths would have been valid, but I think the research model itself could be applied for a survey-based statistical study.
I have another question myself, since there are not more. We have 3 more minutes, so if anybody has new questions, they should add them in the chat. But my question is, your paper is titled "What Prevents Finnish Women?" So if you had now to guess what the opposite question, what enable women to enter software engineering, the software engineering roles? What is your hypothesis?
Oh wow, that's a tough one, especially since going to international audience. But as an educator, I think it would be that it would be at all levels. The structures would make it natural for any kind of people to seek computing or software engineering career, from like social support structures to, for example, the study counselor at high schools.
Yes, thank you. Thank you very much, all. Then I think if there are no more questions for Antti, I think I want to thank you all. I am so sorry that I had so many technical problems, but we managed anyway to run our session. And I hope to see you again around in the virtual world, and not least to meet you physically at the next versions of ICSI. So thank you very much, everybody, and have an interesting rest of the ICSI conference. Bye-bye.
JC, session chair for the I-17 contract analysis. Welcome to this session. So we have 6 very interesting talk today. The first paper is about how to reduce risk effectively in fixed price software development. So please welcome the first presenter of this talk. The first presenter, please share your screen and start your presentation. Thank you.
Yeah, here we are. Could you also grant us the video?
Yes, please.
Okay, here we are. So you can see us and you can hear us?
Yes, please.
Perfect. All right, so here we go. My name is Niklas Spitzog. I'm responsible for the project management at Adesso, and with me is
Volker Grun. I have the chair for software engineering at the University of Duisburg-Essen in Germany.
Thank you. So we are talking about how to reduce risk effectively in fixed price software development. This is a rather long title, and this is because it's not really, well, that easy to do it. First of all, let's have a look at the problem in general. So we say acting early in project management, in software project management, pays off. So we took an example here from the ships. As you can see on the left side, we have a cruise ship which is in calm waters, and on the right side we have a ship that has been wreaked havoc. And what we know is that in the beginning the controllability of the final product is pretty high, and in the end, when you have well, a problem or lots of issues, you cannot control any longer the outcome of your project, really. So what it means is you have to act pretty early, and that totally corresponds with the total cost of the final product. So in the beginning, if you take the ship on the left side, it's pretty easy to go around a storm, but if you're in the storm, then you probably have to pay for it. So acting early really pays off. What we did for that is we investigated the data that we derived from our projects at Adesso. So there was a student, Christian Schürhoff, at University Duisburg-Essen, who evaluated more than 620 Adesso projects from the years 2011 to 2017 with different types, and 350 projects we identified as fixed price projects which are relevant to our research here. And then in total, we had more than 350,000 re-estimations, which means we are re-estimating the project, the fixed price projects, on a weekly basis. Plus, in addition, we had traffic light indicators, more than 3,000. That must be explained. We are working with traffic lights for the most important indicators of a project, which is, are we in time? Are we in budget? Are we in quality, for example? And the traffic lights are usually green, yellow, or red, depending on the data behind that. The basis for all this were the projects as laid out here. So as you can see in the top left corner, it's the total number of software projects in the years 2011 to 2016. And as you can see, in the year 2016, the number decreased. And the reason for this is simply because we changed the ERP system and we could not really migrate the full stack to the new system. So this explains the lower numbers in 2016. In total, what you can see, or let's have a look at the budget first. As you can see over there in the middle, as you can see is, although the total numbers of projects did not really change completely, the budget of the software projects increased significantly. And that also counts for the average budget. And that means in total that the risk per project is increased from year to year, which also means, if you remember the shipwreck, it pays off to act early. So we want to act as early as possible to avoid such havocs. What we also did is we investigated the overspend in percent of BAC. BAC is a figure taken from the earned value analysis, which I will not explain here, but the BAC is the general budget that you have per project in staff days. So this is our currency at Adesso. And what you can see in the year 2012, we had a total overspend of nearly 50%. And in the year 2018, also it increased a bit. We had only about 10%. So that means in total, there are lots of factors around what we are doing here, but we believe that the effects of that, what we did to well, identify problems and issue early, they show and they pay off. Now something about the findings. And the basic question of that, what we did was, do the traffic lights of the projects are really reliable? Are they, if it is green, does it really mean that the project is green? And if it is red, does it really mean that the project is going to recover? And the simple answer is, well, it doesn't work. So the traffic lights are not really useless, but they are not of the use that we hope that it would have. So that means we have to have alternatives, and that is the cost performance index, which is earned value divided by actual cost. And that is required to understand how much we get paid per hour where we work. And this is where I hand over to Volker.
Yeah, so here you see the CPI, which is really the basic indication if the progress corresponds to the effort spent. And we investigated all these projects, coming from the lucky situation that all these projects over time have been reported and observed in exactly the same way. So we took advantage from the situation that all these reports, all these project data was available. What you see on this slide is that all projects were divided into deciles. That means different colors indicate the best down to the worst projects. So you see the bottom line, the light blue line, that are the worst projects. That means those which had the most problems with the CPI. That means more or less all of the time, more effort has been spent corresponding to the progress taken. That means at the end of the project, so to say, a number of work packages have been left which had to be dealt with without any budget left. And on the top line, you see the best projects, the dark blue line, which means that the work had been done with some budget left at the very end. And what you can see on this overview already is that the 80% of the project in the middle, that means letting alone the best 10% and the worst 10%, are rather close to each other, and these do not change after, well, about 40 or 50% of the project time. For the best and for the last, for the worst and for the best 10% of all projects, the situation looks a little different. First of all, we see that the light blue line, that means the worst projects, are really below these CPI of 1. That means budget is left for mainly all over the time. And on the other hand, the best 10% are better, also more or less all over the line. What you also can see on this line, on this diagram, is that the first 10 or 20% of the project time are a little bit erratic. That means projects jump up and down in terms of CPI, and that's mainly due to some sort of project forming and storming, getting staff together, get people knowing each other well enough in order to work efficiently. What you see on the next slide is a little more detail on that. That means a normalized view. And here you see in more detail what happens to this project. And what immediately turns out is that after a third of the project, that's the orange background here on the first third of time, after that, things do not change that much. Even though people and project managers usually report that now things are getting better, you see after this third, things do not get better at all. And we are talking a big bunch of projects, and so we believe that that is really an important finding, that if the CPI is below 1, that means more effort needed to do the work after 1/3 of the project time, then things do not get better over time.
Yeah. And this is why we are somehow challenged with that situation, and we needed to come up with something to find out the first, in the first third, those projects that are below the line, right? Because all the others, they can run smoothly through the entire life cycle. But identifying those is important. And what we identified, what led to that, were 4 pillars mainly. The first is a reporting amnesia. That means we have project managers, they report to management although they don't have a clue. Well, that is a bit unfair, but they don't really state exactly what happens in the project because they either don't know or they don't want to tell the truth, which is difficult. So you need to find out who is doing things like that. The next thing in fixed price project is always difficult if you act without order. That means, for example, that you execute scope that is not paid for, which is a problem in fixed price projects, because that is acting without order and that is doing something that is not paid for. And then there is a pain deferral. You all know that if you, for example, have a tooth that is aching, you can say, okay, let's go to the dentist in like 6 weeks, maybe it's getting better. But
okay, excuse me, time's already up, so can you wrap up soon?
Okay.
Sorry.
And then finally, we have the methodology devoutness. That means somebody sticks really to the methodology without respect of the project surroundings. The solution for that is we came up with tools for each of these pillars. I'm not going to explain them right here because I don't want to take the time from the others. It's all in the papers. The good news is we identified tools to help that situation. The bad news is they do not always work, right? And so we still have to keep a close eye on all the projects at Adesso. Thank you.
Okay, thank you. So is there any questions from the audience? I cannot see any questions from the leader, but the thing is that time is already over. I'm really appreciative for your interesting talk. So then let's move to the next topic now. So please, next, I think that Jumer will prepare for the pre-recorded video for the demo talk. It's about SEPRA enabling cross-platform security analysis for EVM and WASM smart contracts.
Hello, everyone. My name is Han Liu, and I am from the Oxford Hainan Blockchain Research Institute. I will be talking about the Seraph tool as a cross-platform security analyzer for smart contracts. This is a joint work with my colleagues and Professor Wang Lei from Shanghai Jiao Tong University. So basically, smart contract is a program on blockchain to manage digital assets, for example, cryptocurrencies. As we can see here, Alice is able to transfer her money to a set of recipients by calling the batch transfer function in the contract. But the problem is the contract itself can be vulnerable. In this case, due to an integer overflow bug, Alice would be able to send money out without any real costs. Since such vulnerabilities can make persistent consequences on blockchain, we have seen a lot of research works trying to detect vulnerable contracts in recent years, especially on the Ethereum blockchain. As more and more companies and blockchain providers have been developing and promoting their own smart contract platforms, it would be great if we could have cross-platform security analysis. We have designed and developed the tool called Seraph to perform security analysis for smart contracts across different platforms. More specifically, Seraph provides architectural support for two mainstream infrastructures, EVM and WebAssembly bytecode, respectively. Source code contracts from a specific platform is taken as input and then transformed into a control flow graph. Based on the CFG, Seraph is going to symbolically execute the contract. Users are allowed to implement a group of connector APIs which help Seraph understand how the specific platform interacts with the blockchain. For example, we have the get blocked hash interface to abstract the process of retrieving a block hash value from the blockchain environment. Moreover, we could have load and update storage interfaces to specify how blockchain state is accessed. The symbolic execution process will generate a symbolic semantic graph or SSG to enable security analysis in a platform agnostic manner. For example, the balance update in this case is encoded as two value dependency edges and two control dependency edges. We have also provided an SDK to help developers create their own SSG extensions. The security analysis in Seraph is then realized by searching the SSG graph. Seraph is currently a web service. You can perform a push-button analysis and look into anything reported. If you are interested in our work, please refer to our paper and a longer version video. Thank you and take care.
Welcome to our session about how to reduce risk effectively.
Okay, thanks for the presentation. So it's a nice work. So is there any questions from the audience? So I think we have enough time to deal with several questions for this demo. So let me give one question. So did you actually apply your tool for, so how many projects to validate your system?
So we will actually evaluate the tool on a real-world deployed smart contracts from large platforms or such as the Ethereum, the blockchain, right? And also we have tried, because in addition to Ethereum, there is not a benchmark or very large open platform which has already deployed a lot of smart contracts. So we gave our tool to specific companies to try their internal smart contracts. There will be several, but not too many. Yeah, so we have a comparatively large scale evaluation on the Ethereum platform, and we'll also try our tool in some other smart blockchain applications or smart contracts inside a specific company. Yeah.
Oh, okay. Is there any questions from audience? I think there is no question. So let me ask one more question. So I was wondering that is there some systematic taxonomy for any security issues from the smart contract?
Sorry, excuse me. Can you repeat?
So
the question?
is there any well-organized types of security issues from the contract?
Oh yeah. Actually, there are some types of classification of typical smart contract security issues. There are some low-level smart contract issues like on not well-handled exception calls and like re-entrances and integer overflows, things like this. I think the general idea of our work, our tool, is that in terms of this well-known types of security issues, we would be able to design and develop a specific analyzer to help analyze and find such kind of issues. But there, so we're thinking that in the future there will be more like new types of security issues in the future on different smart contract platforms. So the general idea of this tool is that we give you the framework and SDK for those developers. So if they would like to design or maybe create a new types of analyzer, they would be relatively easy to do that on our framework. So that's the key idea. So in general, in principle, there are no specific limitations on what kind of analysis that you can do or you cannot do on this platform. Yeah, but we're currently supporting typical classes of security issues, but you can always make an extension on this platform. Yeah.
Okay, thanks for your detailed answers. Okay, then let's move to the next topic, which is about escape analysis of Golang. So please welcome the next presenter.
Okay, thanks, JC. Hello, everyone. My name is Cong Wang. Today, I will present our paper, Escape Analysis of Golang. Memory management is significant for software engineering. Escape analysis is an algorithm to determine the scope of pointers, and it's an effective way to optimize memory usage. Although escape analysis is very helpful for memory optimization, its algorithm could hardly be completely correct. If a large object is moved to heap memory but is not being accessed externally, it leads to a waste of heap memory. Memory optimization on escape analysis is challenging from two major perspectives. First, our approach should be able to optimize the Golang program to bypass Golang's escape analysis mechanism and reduce the memory usage. Second, the optimization task requires that the optimized program does not have problem with memory readings and writings. Execution of optimized Golang programs should not crash or change. In this paper, we propose an escape analysis optimization approach for Golang, aiming to save a heap memory usage of programs. Our approach consists of three main phases: escape capture phase, optimization phase, and correctness verification phase. First, the approach requires Golang programs as input. In escape capture phase, we compile the source code and analyze the log records of the garbage collection. Then in optimization phase, we optimize the source code. We print the change code snippets and save the optimized code. Finally, in correctness verification phase, we verify the correctness of memory integrity by ASD-based and LVMIR-based verification methods. We use listing 1 as an example to illustrate the approach. The optimized code of listing 1 is shown in listing 2. The Golang compiler does not find a connection between the variable obj and the variable I. Therefore, compared with the original code, only a pointer escaped to the heap memory. We make a comparison of the memory usage for these two code snippets. From the comparison of data, we can draw a preliminary conclusion that the use of heap memory is reduced through this optimization algorithm. In this paper, we do optimization for an escape analysis situation in which a pointer variable is used as a function argument. When this situation happens, the Golang compiler decides to move the pointed object to heap memory. Sometimes this choice leads to a waste of memory. Escape capture phase aims to compile Golang projects and capture information of escaped variables of the above situation. Details of the escape capture are present in the algorithm 1. We record the terminal logs of compilation. Then we will use this information to pick some escaped variables, which is caused by the function arguments. In the optimization phase, we will optimize the code to bypass Golang's escape analysis algorithm and to optimize the heap memory usage. The original code passes the normal pointer to the function call. This situation is considered to be an escape. Our method is to do the transformation between the normal pointer and save the pointer and the uint ptr. Then we rewrite the optimized code into the source file. The verification method adopts an effective and secure strategy to make decisions on verification. The validation of the memory integrity is challenging from two major perspectives. First, sensitive to bad cases, and the compatible with multi-threaded code. The algorithm adopts two strategies to verify the memory integrity: ASD-based and LVMIR-based verification. We choose real-world projects to construct our dataset. Some projects are collected from GitHub. Meanwhile, we also collect some industrial projects which are used in companies. For each Golang project, we calculate the metrics in 2 dimensions: the memory usage and the time consumption. Figure 4 shows the optimized case on the open source dataset. The most important column is change. It represents the effective of the optimization approach. Through analyzing the memory optimization effect on the open source dataset, we can conclude that our optimization method can achieve the effect on various metrics used in memory. Among these groups, the heap alloc is reduced by 8.88% on average. The heap usage is reduced by 8.78% on average. On the issue of the memory optimization, we should not only focus on the memory metrics, but also the impact on the speed of the code. Among the groups of optimization, time consumption is reduced by 9.48% on average, and the cumulative time of GC pause is reduced by 5.64% on average. Listing 4 shows an optimized case in the open source dataset. It is noteworthy that the variable actual message, this variable. It's moved to heap because its pointer is passed to the function call in line 6. Optimized effect of these metrics are shown in figure 5. These 6 figures illustrate the comparison between the original code and the optimized code. We try to feed a long string for this variable. The large variable is moved to the heap, leading to the rapid rise in the 9th spot of the group before. On the other hand, the change of the group after is smooth. With the optimization variable, actual message should stay only in the stack. Here we will present the experimental results on the industry dataset. These optimizations have been confirmed and adopted by the senior developers in companies. From the study of the optimization on escape analysis, we have learned 3 important lessons. The first, the optimization of Golang's escape analysis algorithm is a significant issue. The second, guaranteed memory integrity is a very high priority requirement for Golang's memory optimization. Finally, change the code is an effective way for memory optimization. In this paper, we have proposed a memory optimization algorithm on the escape analysis algorithm for Golang. In the future, we will continue to study the memory optimization problems. And thanks for the advice from the reviewers, and thank you for listening.
Okay, thanks for the great study. So now it's a Q&A time. There are actually 2 questions from the audience. So the first one is, does your approach have a significance over how long the compilation takes?
Thanks for the question. We just changed the code to optimize the algorithm, so it's not measured in our experiment, but theoretically it does no harm to the compilation time. Yeah.
Okay, and then next question is that is your approach useful if no unsafe pointer is used in the code?
Unsafe pointer is a structure that we use to transfer the ordinary pointers. So we focus on the situation when some pointers are used as function arguments, and we transform it to unsafe pointer and to the uint_ptr. Sometimes this transformation is dangerous, especially in the multi-threaded programs. You know, Golang is good at the concurrency situations, but we do the verification to confirm that the optimization does no harm to the security of the runtime. So that's about this question, JC.
Okay, thanks a lot for the answering the question. So I think we have several minutes now. So is there any other questions from the audience? Just let me wait for just 1 minute. Okay, if there is no question, then let's move to the next talk, which is a journal first track paper. It's about smart contract development, challenges and opportunities. So please welcome the presenter from this talk. So you can share your screen and then you can start your presentation.
Okay, sorry, share. Optimizing Keynote. Sure.
Excuse me. So can you start your presentation for the paper?
Hello, can you hear me?
Yeah, I can hear you. Can you please share your screen?
I cannot share my screen. I'm trying to understand why. Sorry. I cannot show my screen.
Okay, then.
Oh, okay.
Okay, then we'll play your backup video instead. Okay.
Okay, okay, thank you. What? How come? Hello everyone, I'm Wei Qin from NUAA China. I'm very glad to introduce our work in the journal first track of ICSI. My topic today is smart contract development, challenges and opportunities. Smart contract was originally coined to refer to the automation of legal contracts in general. Recently, it's popularly used to refer to low-level programs running on a blockchain, and we also focus on the letter-specific definition of smart contract. A smart contract program can be automatically executed when certain preconditions is met. This is a smart contract written in Solidity programming language. It defines some cell behaviors using buy and sell functions. As shown in the right picture, there are a list of blockchain platforms which support developing smart contracts, including Ethereum, Neo, Corda, and so on. Our study mainly focused on the Ethereum platform, which is the most popular public blockchain platform for smart contracts. The self-executing nature of smart contracts provides a tremendous opportunity for use in many fields. More and more developers and researchers are devoting themselves to the new area of smart contracts. Despite the increasing popularity of smart contracts, the potential challenges that developers are facing when developing smart contracts have not yet been clearly explored. To help advance research in smart contract development, we conducted a study to explore the work practice and potential challenges faced by developers during smart contract development on blockchains, with a focus on Ethereum. This is an overview of our methodology. Our study includes two parts, the interview part and the survey part. The interview part is to get insights from expert developers into smart contract development, and the survey part is to validate the findings of the interviews. In the interview part, our participants were from both GitHub and the industry, whoever worked on smart contract projects. We sent emails to invite them to participate in our survey interviews and also ask them for help to introduce their friends or colleagues for interviews. Finally, we had 31 interview candidates. For those candidates, we conducted semi-structured interviews through Skype, WeChat, and Google Hangouts. That is, we used some open questions listed in Table 1 to guide the discussion. We also asked follow-up questions to dig deeper into our interview participants' viewpoints when appropriate. We stopped interviews when situations of findings were reached. Finally, we interviewed 20 interviewees and obtained 20 audio recordings under the permission of interviewees. Table 2 listed the basic information of 20 interviewees. Then we performed audio recording, transcription, text segmentation, and card sorting on the interview comments. We obtained hierarchical categories of findings. After that, we designed a survey questionnaire to validate the insights that we got by analyzing the interviewee comments. Our survey included both demographic questions and smart contract questions. We sent our survey invitations to randomly selected 2,000 GitHub developers on smart contract related projects and some industry friends. Finally, we got 232 respondents. By analyzing the voting results and the survey comments, we got an overview of the current challenges developers are facing in their smart contract development. We obtained 6 major categories of challenges developers are facing during their smart contract development. They are related to code security, debugging, Solidity programming language, Ethereum virtual machine, gas, and online resource and community support. These are 28 challenges and desired improvements mentioned by interviewees. In the table, C1 to C6 were 6 major challenges on the whole of smart contract development. C7 to C17 were challenges developers were facing during different stages of smart contract development, for example, coding, testing, debugging. I18 to I28 represented the desired improvement of solidity and EVM respectively. The last column is the number and ratio of respondents who voted for the corresponding challenges or desired improvements. For example, for the C1, we found that 71.6% respondents voted that it's hard for them to guarantee the security of smart contracts. And for the brand new programming language and virtual machine, particularly designed for developing and running smart contracts on Ethereum, respondents voted the most desired improvements. For example, the I18 shows that 53% voters hope Solidity could support or provide more general-purpose libraries. Based on our results, we further summarize some future research directions, such as developing tools to prevent vulnerabilities spreading further, transforming features from other virtual machines and programming languages into EVM and Solidity to make developers' life easier. Okay, this is my talk. Thank you so much for your attention.
Okay, thanks for the case study. About the smart contract development. So is there any questions from the audience? Okay, so there is no questions. So let me give one question. So I was wondering that based on the current findings, so are you working on any kind of implementing practical tool for the contract development now? So as you said in your future work. Hello? It seems the internet connection is not that stable, so I cannot hear your voice. Hello?
Hi, maybe I just comment on that because I'm also an author and seems the Norwegian internet connection has an issue. Is it
okay? Okay.
Yeah, so I think now we are actually working on a few things related to the smart contract. Like first, we are looking into like smells into smart contract and ways to detect them. But certainly there are many opportunities that are highlighted in our journal paper that we need open. And we will encourage more people to actually work on this area on addressing the challenges that practitioners find to be important.
Okay. Thanks a lot for answering the question. So actually, I'm not familiar with this area yet. So I also was wondering that are there any practical tools to support current challenges now, or just as it is just ignoring techniques? Still, there are a few tools to support development, contract development.
I think at the moment there are tools that support development, but the current tools are not mature because many of the languages and the existing IDEs are pretty new as compared to other languages and other software. So I think there is a lot of opportunity either to migrate the existing tools to smart contract and also to actually build new tools considering the specific characteristics of smart contracts. So among the people that were interviewed and also surveyed in the study, many of them highlights like clear challenges with no existing tools at the moment, or the current tools are not enough to address those problems. And I think there is a lot of potential for future work in this area. So we just want to highlight all these challenges and hopefully excite people to work on the problems.
Yeah, thanks so much. Yeah, I agree with that. Your study will stimulate many researchers to work for the solving the software engineering problems in developing smart contract. Okay, thanks for your great work.
Yes, thank you very much.
Okay, then let's move to the next talk. It is about empirical leave of automated analysis tools on 47,000 Ethereum smart contract. So this presentation is provided by the pre-recorded video first, and then we will have a live Q&A session.
Hi, I'm João Freire, and I'd like to present an empirical review of automated analysis tools on 47,587 Ethereum smart contracts. This is joint work with Thomas Goguryeo, Rui Abreu and Pedro Cruz from INESC-ID and IST, University of Lisbon in Portugal. Blockchain has received a lot of attention for its promise to change the world. It has been used to secure digital art, to implement games, to track container ships, and it was even proposed as a solution to political issues. Many people believe that blockchain will disrupt many industries. One of the most popular blockchain platforms is Ethereum. Key to its popularity is the fact that it enables developers to write so-called smart contracts. These are programs that are executed across a decentralized network of nodes. The main language used to write Ethereum smart contracts is Solidity, a high-level object-oriented programming language. Smart contracts are at the core of Ethereum's value. However, it is far from trivial to write secure contracts. There have been attacks where millions of dollars worth of cryptocurrency were stolen due to security issues with smart contracts. And despite these high-profile attacks, serious vulnerabilities continue to appear. This has led to substantial effort from the research community to develop automated analysis tools capable of detecting vulnerabilities in smart contracts before they are deployed. However, it is not at all easy to compare and reproduce this research. Even though several of the tools are publicly available, the datasets used to evaluate those tools are not. If one wants to compare a new tool with existing work, the current approach is to contact the authors of existing tools and hope that they give access to their datasets. And so the first goal of our work was to create open datasets of vulnerable smart contracts that can be used to evaluate analysis tools and enable reproducible research. The second goal was to use these open datasets to obtain an overview of the current status of automated analysis tools for Ethereum smart contracts. In particular, we were interested in understanding what is the effectiveness of current analysis tools in detecting vulnerabilities in Solidity smart contracts. How many vulnerabilities are present in the Ethereum blockchain? And how long do the tools require to analyze the smart contracts? For our first goal, we created two new datasets of Solidity smart contracts. The first is called SB Curated, and it is organized in the 10 DASP categories. It contains 69 contracts with a total of 115 tagged vulnerabilities. Contracts are annotated by tagging lines with the corresponding category of vulnerability as shown in the image. The second dataset is called SB Wild and contains all Ethereum contracts with at least one transaction and with Solidity source code available in Etherscan. We processed more than 2 million contract addresses. We obtained more than 900,000 Solidity contracts, and then we removed duplicates. We ended up with 47,518 contracts with more than 9 million lines of code in total. So, for our second goal, we use these datasets to evaluate existing analysis tools. We started by considering 35 tools, which were filtered according to 4 inclusion criteria. First, tools must be publicly available and support a command line interface. Second, they must support Solidity source code as input. Third, tools should only require the source code with no need for code annotations. And finally, tools must identify problems. This means that tools that only create artifacts, such as control flow graphs, are excluded. At the end of this process, we ended up with the 9 tools shown in the slide. To facilitate the execution of the analysis tools, we created SmartBugs, an executional framework that supports a plugin system based on Docker images, parallel execution of tools to speed up execution time, and an output mechanism that normalizes the way the tools are showing the results. We then use SmartBugs to execute the 9 selected tools on the datasets SP curated and SP wild. The results are as follows. When considering the smaller dataset, the results show that the 9 tools are only able to detect 42% of all the vulnerabilities. Moreover, they underperform in 3 categories: access control, denial of service, and front-running. Mithril outperforms the other tools by the number of detected vulnerabilities. We also investigated the combination of different tools, and we observed that the combination of Mithril and Slither detects 37% of all vulnerabilities, which seems to be the best trade-off between accuracy and execution costs. Regarding the second research question, we used the larger SP wild dataset. In this case, the 9 tools identify vulnerabilities in 93% of the contracts, which suggests a high number of false positives. Oyente alone detects vulnerabilities in 73% of the contracts, mostly of the category arithmetic. Since we observed the potentially large number of false positives, we analyzed to what extent the tools agree in vulnerabilities they flag. The hypothesis is that if a vulnerability is identified exclusively by a single tool, the probability of it being a false positive increases. The blue bars in the figure show that the large majority of the vulnerabilities have been detected by one tool only. The categories arithmetic and reentrancy are where consensus was higher. Finally, regarding the final research question, we observed that on average, the tools take 4 minutes and 31 seconds to analyze one single contract. Slither is the fastest tool with an impressive average of 5 seconds per contract, and Manticore is the slowest tool, taking on average 24 minutes to analyze a contract. In summary, we have created 2 new datasets and an executional framework called SmartBugs that enable reproducible research in automated analysis of smart contracts. We use them for a large empirical review, and we found that there are many opportunities for improvement. We also found that the combination of certain tools might give better results. As next steps, we intend to continue extending our curated dataset, add new tools to SmartBugs, and use some of our findings to improve existing tools. All our datasets and code are publicly available. If you'd like to collaborate with us, please get in touch. Thanks for listening.
Okay, thanks for the interesting talk. So it seems like there is no questions yet from the audience. So I have some questions for you. So from the research question too, there are many high ratio of false positives. So I was wondering what are the possible reasons for those many false positives?
Okay. Well, first of all, we because the biggest data set is not annotated, the fact that we say that there are many false positives is just a conjecture. So we haven't really proved. But if you look at the data, you actually see that one of the tools is actually flagging most of the cases. So that's the case of Oyente, which is perhaps the oldest tool, the first tool. It's a tool with a great impact because it then inspires other tools, but it's contributing to that big result. And I think it's 73% of vulnerabilities are actually caught by just one single tool. So that's one of the reasons why the number is so high.
Okay, I see. Thanks for answering the question. And in research question 3, I also found that it took too many days to execute the existing tools. So several days for certain cases. I was really surprised that. So, is there any major reason for taking a long time to execute the tools?
Well, I think in terms of time, you can actually see that we have sort of three classes. So you have the tools that take less than 1 minute, tools that take a few minutes, and then there's one tool that actually takes longer than all the others. You can actually see that tools that are based on dynamic analysis will actually take longer, which that's the case with the slowest tool. Because they have to actually set up the environment and run transactions, and it takes a long time. So the main reason for the discrepancy is really related with that. But we were very impressed. I mean, Slither is very fast. I think it's a modern tool. It's also very well built, and it's based on static analysis. So it's going to be faster than the other tools based on dynamic analysis in general.
Oh, okay. Thanks a lot for your answers and also your data set. It might be very helpful for other researchers. Okay, thanks. Let's
thank you.
Thanks to the speakers again. And we have only one additional talk. It is about an extended abstract of metric plus or metamorphic relational identification technique based on input plus output domains. But I think there is no presenter over this last talk, so I think Joomer need to play the pre-recorded video first.
Yeah, due to the problem on the ICSI conference, the last presentation was canceled. So I think
I canceled.
Yeah, you can manage this, and I think you can finish this session.
Oh, okay, I see. Okay, then let's finish the I-17 session, contract analysis. I'm really afraid for all the presenters and audiences. So enjoy your last sessions in ICSI 2020. Okay, thanks a lot for everyone. Bye, see you.
Thank you.